All right, so wrapping up chapter 11 here. So this is for worksheet 11.5b. So this is a quick summary here. So writing the equation in polar. So let's just do one example here, just to kind of refresh what we've been doing here. So let's say writing the equation of a parabola of y equals 1/16 x squared. So notice I haven't been doing too much shifting, so your vertex is 0, 0. And to find your focus, it's your distance is found by 1 over 4p, which implies that this would be 1 divided by 4 and 1/16, and that would give us 4. So if we stop there and graph it out, so you have 0, 0, and since it's 1/16, it's going to be really wide open. And my focus is going to be 4 units up. So there's my focus is 0, 4, and my directrix is 4 units below. So the directrix is y equals -4. Now, going to polar now. So first thing you got to find is your eca. And your C and your A is all the same, so this is going to be 4, this is 4, and therefore you should always get a 1 for parabola no matter what. Then your directrix is A squared over C, so you have 4 squared over 4, so it's 4. So notice you have that. You need your total distance between your focus plus your directrix. So in this case, it's going to be 4 plus 4, so a total distance of 8. And then if I want to graph in polar, it's ED over 1, and I'm going to go minus E cosine of theta. So therefore, my directrix is going to be below my graph. Okay. And I should change this so I'll go around the y-axis, so not the x, so I got to change that to sine. So I'll go around the y. All right, so if I multiply out, there's 1, there's my eca, 8, and then 1 minus 1 sine of theta. Now, keep in mind how this gets graphed out now is this is your pole. So therefore, you go on 2, 3, 4. Now you're graphing from this pole, so therefore it's going to be like so. And then your directrix is going to be 4 units below that. 1, 2, 3, 4. And therefore, in this case, it's going to be y equals -8 if I actually graphed it out using a more like a rectangular value. Okay. So a quick summary of what we've been doing here. All right. So let's look at one more here. So let's say x squared over 4 plus y squared over 1 equals 1. So my A is 2, my B is 1, and therefore my C, now remember it's always the opposite, so it's going to be A squared minus B squared. So 4 minus 1 is C would be root 3. So graphing this out, about 2 units each direction, 1 unit up on my y, And this would be somewhere in here. Your focus would be negative root 3 comma 0. Other focus root 3 comma 0. Okay. All right, so now let's do my eca. So C is root 3 over 2. My directrix is A squared over C. So that would be 4 over root 3. Or 4 root 3 over 3. And again, that depends which direction you want to put that. Okay, we are on the left side, right side, or whatever. Okay, so notice that would be probably someplace. I'm going to do this one here on the right, or this one over here be on the left side. Okay, so this would be the positive one, and this would be the negative one. Okay. All right, so my total distance now between my focus and my directrix. So I would actually have to subtract these two. 4 root 3 over 3 minus 3 root 3 over 3. And you should get like 1 over root 3 is my total distance between these two values. There's my focus and there's my directrix. So therefore you have to subtract the two, and actually you have to go D minus F to find that distance between them. Okay. All right, so plugging this in again. So if you have ED, so I multiplied root 3 over 2 times my total distance, 1 over root 3. And then you have 1 minus root 3 over 2 cosine of theta. So if you clean this up here, obviously like this, those cancel. So a lot of times they don't want to put fractions in here. So they're going to multiply top and bottom by 2. And therefore what you'll see here then is this 1 over 2 minus root 3 cosine of theta. So it just gives it an easy way to plug all your values in. So the last piece that we're going to work on is actually what to do when it's written like this. Come back and find your other values. Okay, so if you are given, let's say, r equals 1 over 2 minus root 3 cosine of theta, you have to get a 1 here, which means then you have to multiply top and bottom by a half. So therefore you have 1/2 divided by 1 minus root 3 over 2 cosine of theta. I got my 1 there, which means then this has to be my eccentricity. So I have root 3 over 2, and therefore if I go E times D, hey, that would mean that this would be 1/2. So to find my total distance here, well, I know what E is, so it's root 3 over 2 times D equals 1/2. My total distance then is 1/2 times 2 over root 3, and therefore my total distance is 1 over root 3. So it gives me the ability to separate and find my different values. And that's about the last little thing that I put in on here. Just how to come back and find my total distance. Again, that's total distance. And my eccentricity. If we were in the classroom, I would take the time and go over Kepler's 3 laws. Unfortunately, I just do it kind of for the fun of it, to kind of show you some stuff on how this can carry over. There are some YouTube videos. I would suggest to maybe just type in Kepler's 3 laws, watch a couple of them. There's some great YouTube videos of it. I think I put one little question on finding the eccentricity of different planets. Every planet has their own eccentricity, the Earth, Mars, Jupiter, things like that. So you can just type it in on your phone or YouTube, Google it or whatever. It will not be on the test, so don't worry about that. But anyway, take a look at the Kepler's 3 laws, and don't worry about any of that being on the test, but the other stuff will be.